Right, good afternoon everybody. Jason Fox here again. I'll just put myself up on screen. It's a little bit less hot here today than it was yesterday, but I've still got my water with me, and we'll see how it goes. I am the Senior Technical Evangelist at the FIWARE Foundation, and we're continuing slightly out of order because unfortunately Alvaro is unavailable at short notice. We're going to be doing the NGSI LD Advanced Operations today. Now, as usual, if you really want to contact me and you've got questions and what have you, I'll just put my LinkedIn into the chat so that you can actually ask questions. Indeed, given that this is a live event, there is no sense in not taking the opportunity. If you've got any questions, throw them in the chat. If you want to come up on stage and discuss something because it's going to be better than typing it, we can do that. Put your hand up. So we'll see how it goes. I'm currently scheduled to be offering 3 hours of advanced NGSI LD advice and slides and video and blah blah blah, and that's going to be, and it's taking some time to start up for me. I don't know if you can see it on screen yet. It should be coming up. Great. I haven't got that many slides. It's more actually a mechanism to actually talk around the various subjects. Now, the subject I had yesterday, I was talking about the basic operations of NGSI. These are the operations in NGSI which are already available in NGSI v2. I believe they're even available in NGSI v1, and they're not particularly spectacular. Things like standard CRUD operations, you get your subscriptions and you get your registration. That is FIWARE in a nutshell. Now, there's an awful lot more to the current NGSI LD specification than just the CRUD, the subscription, the registration. And I'm going to spend some time looking and demoing a few of the useful, maybe obscure, maybe you don't need it, maybe you do, sort of areas, explaining what you do and what you need it for. And let's see if I can move the slides on. I can move the slides on, amazingly. Right, so useful links. The current specific NGSI LD specification is 1.4.1. I believe 1.4.2 is actually in the process of being released. And you can see the full details. It's a dry document. It's an API specification. What do you expect? However, it is the sole source of truth of everything NGSI LD. This is the document which is created by Etsy, hence it's in the etsy.org website, and therefore it is created by consensus by manufacturers of context brokers and other interested parties, and this is the way forward, which means that if you don't like broker X, you can always try broker Y. It makes no difference. Obviously, there are multiple brokers in the FIWARE catalog, and for NGSI LD, you're talking your choices between Scorpio, Stelio, and Orion LD. Classic Orion is just using NGSI v2, and typically advice I would tend to give is if you're doing for a massive federated environment, then Scorpio is the one to go for. If you're trying to get a small environment, say on the edge, or indeed for most of the tutorials, then the quickest one to start up is Orion LD, and Stelio kind of bridges the gap between the two. It's kind of a middleweight out of the three of them, but it will very much depend on your use case, which obviously is unique in each case as to which way of doing it is. So I can't say, this one's better for you, this one's better for you. It will depend, as you would expect. Anyway, let's move on to the next link. There are a series of interactive tutorials on NGSI LD, and indeed all of the stuff which I can show you on videos yesterday, plus the stuff which I'm showing today, and other aspects like how to generate your at context, and what your at context is in the relationship between NGSI LD and JSON-LD, is available online on the tutorials. The tutorials also link to various videos direct from the JSON-LD people, because there is obviously an intimate relationship between NGSI LD and JSON-LD. One question which I was asked recently is to define. I'm confused about what JSON-LD, what NGSI LD is. What's the difference? What's one? What's the other? Well, it's relatively easy to understand. What you need to realise is that JSON, which I'm sure you're all familiar, is a data format. It's curly bracket here, colon there, inverted commas there, and so on and so forth. And that's all that it is. It doesn't actually have anything else to it than that. Whereas NGSI is an API which uses that data format. Therefore, similarly, JSON-LD is standard JSON plus this little at context attribute, which has then got various other bits of meaning as to saying what the dictionary value for a short name is to a long name, an IRI, and then that in turn has real meaning as to what this attribute actually means. Fine. Now, the same goes for the difference between NGSI and NGSI LD, in that NGSI LD is NGSI v2, which is the JSON, purely JSON-based format. Plus, it's you can do everything you need. Plus, being able to offer this at context file, which is what I was describing yesterday, saying how you can get a computer-readable definition of what's going on, what's happening. So that's the nutshell of the different. Every NGSI LD, normalized NGSI LD payload is valid JSON-LD. However, the reverse is not true. You can have JSON formatted in whichever way you like. It doesn't necessarily have to have these things like properties, relationships, geoproperties, and what have you. And that is necessary. It's a necessary addition to the NGSI bit rather than the JSON bit to talk to a context broker. If you're ever talking about, I am putting stuff into a context broker, getting stuff out of a context broker, you're probably talking NGSI. If you're just doing a web page which has got some information which you want to share or to third parties, you've moved out of the context world and you moved into just standard data exchange, then that could well be JSON-LD instead. We also have a Swagger specification for the API. This is saying the difference between the payload and the API is the main point here, which means that you can easily generate little stubs for doing all, I think it's 27, I always count it's 27 actions. That, again, these 27 things are all specified in that 250-page specification document at the top, something like that. So it's much easier just to say, okay, just generate me my stubs. Obviously, you can do this stuff with things like Postman as well. It's quite easy. And finally, as you probably realized from yesterday's presentation, data models are going to become an integral part of how we exchange data between systems which have not necessarily been designed to be part of the same thing. You know, we've got to agree rules, like, what's the name of this attribute? What should it hold? And that is all through data modeling. Smart data models have got stuff on there. Etsy have got stuff on there. Read the links and find out what you're interested in. Right, so let's have a look at some headers. When we have some requests, you can modify the payload, or you could modify the visibility of elements. Back in NGSI V2, there were two specifically FIWARE headers, one called FIWARE Service and one called FIWARE Service Path. Now, the NGSI LD specification is under the auspices of ETSI. It's not just FIWARE taking part, and no organization would want to be specifically using our FIWARE Foundation name in it. So the names of the headers, although the purpose of the headers have not changed. Now the old FIWARE service path is now called NGSI LD 10, and NGSI LD is in capitals, and it is used for multi-tenancy. You can imagine a situation where you have multiple users, each with their own data, wanting to push to a single context broker, and you want to separate the information. One of the reasons why the NGSI LD 10 header was added to the specification first was that you could have legal reasons for separating your data from someone else's. So therefore, this is effectively used in the backend databases for disaster recovery. It is also used for the historical databases for the temporal functions, should the optional temporal interface be added. And therefore, if you want to make sure that your stuff is separated from someone else's, you need to have a way of doing it. Obviously, we don't care within the payload itself. Payload itself is just describe the entity, but the header, and I give some examples in a little video a little bit later on, showing where we can do this. The important thing here to remember is that although context brokers are implicitly multi-tenant, the default NGSI LD tenant is blank. So you can easily make a request and find out, hey, there's nothing in my broker. And it's probably because you're using the wrong header. Now, typically for IT agents, which we again dealt with later on in this course, we will end up using some sort of tenant for each set of devices, and therefore I'm no longer using the default tenant. Therefore, I need to supply the header when I'm doing it. My advice again would be to say use your headers, use them wisely. Now, NGSI LD scope, which is not defined in the existing specification, but I believe it's in 142, or it's under discussion for 151. I can't remember which. Is the equivalent of the old FIWARE service path, which gives you a logical division of your, as it says, services. So you can use this when you need to make filtering queries within a division of objects. The classic example given is you want to get information about a particular flower bed in a particular park in a particular city, for example, and you can use that to reduce the burden on retrieval of data, and therefore you'll get a quicker response time if you put the service path in there. It is a hierarchy. I think it defaults to slash if you don't put it in. So it's slash or slash star. I can't remember. And obviously, if you do put in an explicit header, it will come through. For more on the headers, you have a content type header. There are 2.5 types of which are supported. I think I do half in the next slide, where you've got either application JSON or application LD plus JSON. Now you can see on screen the difference between the two is that if you've got application /LD, it's got to have an at context, because that means the the exported payload is JSON-LD. For data exchange between multiple systems, like i4 Trust, for example, you are almost certainly going to want to use LD plus JSON, or you will need to be talking to a direct from broker to broker. in that I have the NGSI LD by default assumes the core context, and if you don't supply a header in the payload body, the dog is barking. I'm just going to tell it to be quiet for a second. So if you don't have to put it in the body, you can put it in a link header. Link header being the standard way of adding additional information to an HTTP payload. It's all defined by HTTP statistics. So if you look on screen, you've got one which has got the at context in the body, and the other one hasn't, the one at the top, and that would just have that link header in the response, as well as saying, yeah, if you want to find out all about what the at context stuff is all about, it's over here. Now, obviously, if you're talking about broker will be able to understand both of those formats. However, it could be a third party where you're now getting out of the context world, in which case they would have to deliberately read the link header using a standard library and then get hold of the at context as necessary. In general, it is preferred to use the link header for the simple reason that when you have an array of entities, you would get a repeated at context attribute in the body of the response for each entity, and therefore it's going to increase the size of the payload. So for efficiency reasons, particularly when you're using get of entities plural, then you want to make sure that this is the way going forward. Still going on the headers, there's an accept header. I can either accept as well as the payload, which is going in, content type. The accept header is what's coming out, and again, this is all standard HTTP stuff. And the additional half of the exported accept type, as I said earlier, is Geo plus JSON. The browsers are holding entities. Entities tend to be, not exclusively, tend to be things in the real world which have got some sort of state. Things in the real world tend to have a location, and therefore it is useful to be able to take out information in a Geojson format, Geojson being particularly popular with GIS systems. So if you want to, say, display something on a map, you can then just go straight out and say, hey, here's my stuff. Here it will cut where the various points are. There are the fallback, the default, the assumption is that if you have an error message, for example, because you've specified I can accept either JSON or LD plus JSON or Geo plus JSON, then you can accept application JSON, and therefore your error message will always be in JSON LD. Now, you can. There are two basic NGSI formats, NGSI LD formats, which are normalized and key values. Default is normalized, which is the expanded one with types and values in it. However, it is also possible for both get of entities or payload of a subscription to ask for key values format as well. There are other alternative formats which may be supported. If they are, this is beyond the scope of the ETSI specification. So ETSI specification just says normalized or key values, but other brokers, for example, Orion LD, also support a few extra formats. Orion LD supports X because it's custom minus NGSI v2 normalized key values and compacted, because that way you can create subscriptions for legacy systems. If you've already got an existing FIWARE component talking NGSI v2, but it doesn't yet understand NGSI LD, and they're slightly different, but it's not massively different, you can just say, okay, whenever something happens to my context, I want to receive the value in the older format, which is appropriate for NGSI v2. Obviously, recommendation is that if you are doing data exchange, then you need to use the standard formats which are defined within the NC specification. Okay, I won't go on to that slide just yet. I'll just go back and move on to one of my little videos. I've got one on headers, so let's share that instead. Present to audience. There we go. I've got my Postman application up and running, and you can see I've got things like OpenIoT, NGSI LD tenant, and my link header. And at the moment, I'm accepting the format of JSON. Let's see what happens. What am I going to do? Well, you can see I'm highlighting the various links, and you can see that this is currently looking for alternate context, which is going elsewhere. I'm getting hold of an animal, and I'm asking for this in key values format, which is in my parameters. And you can see if I worry about my animal, it's now showing me an animal here, which is in German, and you can see that the type has changed, and you can see that some of the attribute names which I've put in the system, like ID is now rechtliche Identität, and Herzschlag is heartbeat. Not all of these are obviously different in German anyway, but it does show that some values cannot be, and this is deliberate, easily renamed. There are a few key names like name or type or ID or location, which are not overridable. They are required to be name, type, ID, location, because these are used for things like the definition of entities or the location geofencing type stuff. So you can't do much else. The other ones, the reasons why phenological condition and reproductive condition have not changed is because I haven't bothered putting them into my at context. Therefore, they fall into the default at context, and therefore they keep their existing name. Now, if I get rid of the key values element, you can see the same entity comes up, and it's much more verbose. This is normalized information. This is what you would most likely want if you wanted to be a talking machine to machine, because the machine doesn't understand what a location is likely to be unless it's given sufficient information to tell you. You can see that the location itself is a geoproperty, and indeed it's got additional metadata, like it was observed at the following point in time about half an hour ago. And then it was also provided by a particular device attached to the animal in question. This is classic use of metadata. And if you remember, when doing the key values stuff, you don't get this additional metadata as well. You just get what is the state of this particular entity in the system. This is my cow. My cow is currently happy. Looking at the headers, I think I changed the context back to ordinary context at this point. And we do the same thing. You can see, once again, we get back to saying things like heart rate and location. And indeed, you can see, because I've got an application JSON, I've got the stuff down in the link header as well, which is being shown on screen. If I change it to application LD, it's no longer in the return content type, and you get this additional at context into the file in question. Okay, so we can do Geojson. Geojson is a new addition in 141, I think it was, which is able to return the values in a different format. Now, it consists of two parts, basically. Firstly, the fairly obvious thing is that you need to set your accept header. But there's already a standard MIME type for Geojson. So it's going to be application geo plus JSON, which kind of it makes life a little bit tricky, because we have this, do we want the at context in the response or not? You've already got the options attribute, so you can do that to make it whether it's normalized or non-normalized. But the question here is, do you want to have an at context attribute? Now, the Geojson specification is perfectly capable of accepting an additional attribute in its properties. It's called a foreign property, which is ignored if you don't have anything in the if you don't have anything representing that attribute. But there needs to be a mechanism to do it, and the mechanism to do it is to use the again, we're talking HTTP standards here, the prefer header. We can prefer the body to be JSON, or we can prefer the body to be LD plus JSON. It is therefore possible to get the information back in either with or without an at context, either with or without the names and the types and values for each attribute, and indeed with the Geojson format. The Geojson is going to assume that the geometry of each feature is going to be the location attribute of the entity, and the rest of the properties of the entity are Geojson properties displayed in the properties section of the Geojson. We'll have a look at that a bit later. Now, it is perfectly possible and legal to have an entity which doesn't have a location. For example, you might have a task entity. I think I showed one of those yesterday, where the task is effectively, it's a bridge table which is saying set this worker to that field to do this, to do something else, blah blah blah. Now, if you have an entity which does not have a location, then its geometry will be null, which is perfectly valid Geojson, because Geojson, okay, you really usually use it to display stuff on the map, but it is possible to have a null which just doesn't display. So that's perfectly good as well. It is also possible to amend the default attribute to be used as the geometry. There's a parameter to do that as well. You can see on the actual query I've got there, you've got in English it says, give me all the animals which are pigs in calf within a certain distance of a point. You can see that you can combine various filtering options, like the geometry, the geofencing property, the georel, and the Q parameter, which is used for either oring or anding a series of elements to say only get the following X, Y, and Z. And obviously, you can also use filtering direct by IDs, within a group of IDs, within a or with type as well. Right, let's that's this slide. Okay, yeah, the response is going to be some sort of Geojson response. I'll go back to that slide in a second. I'll just go back to the videos because it's going to be easier to show. Let's go back onto our little farm again. I'm just in the same data set as I had beforehand. Is that moving? Yes, it is. And you can see that I've got a farm somewhere in the middle of Berlin. And on this farm, I've already set up a series of devices, including animal collars around my pigs and cows. And you can see the pig and the cow have got some sort of GPS which is sending some sort of data, which is obviously impossible to work out what they're doing, where are they going, or what have you. But you can see the status is changing. Some of them are moving around. Some of them are standing still. Now we look at the Geojson. You can see here we're making a request which is getting that body, and we get back. If I move this up a bit, just looking at the parameters. We've got the parameters there. Yeah, so I'm saying I'm doing the filter of the Q and the S, and we've got the various attributes coming through for the animals in question. It is then possible to change the format into, again, the default Geojson to get hold of JSON to get hold of Geojson, and it changes to a type of feature collection. It'd be a feature if it was just a single entity. And you can see this is a structure which is well defined. You can see you've got properties, and the type of each entity is actually a feature, a Geojson feature. We can copy that into a GIS system. This is just a simple viewer for Geojson, and you can put the values in, and you can see that my cows are currently standing on Tempelhofer Field in Berlin, and you can get the information about them because the structure of the response is such that GIS systems will be able to understand it, so you can work out which cow is standing where. Similarly, if you make another request, it's slightly different response. It will show that the again, if I copy this to the system, obviously you do it into a proper system rather than the thing. You can see the cows have moved. If we just paste that in, test the Geojson, you'll see that one of them has moved further north, and he's now currently standing on the runway. That's Tulip. So this is a nice to have, which it makes it easier to actually view your Geojson whilst we're at it. So yeah, request has got this body JSON. The response, you have a feature for if you make a request on an entity, for a specific entity like NGSI LD v1 entities URN cow1, you will just get back a feature. However, if you Geojson feature, however, if you do the same thing with a request for entities, and then Q or whatever, so give me all types of animal, or give me all types of animal which are currently in heat or whatever, it is then possible to retrieve a feature collection. Both of these are, funnily enough, standard Geojson attributes, which are, just a minute, standard Geojson attributes, which can be easily digested, and they are the two types of attribute which cannot, and I'll repeat this, cannot be used as location attributes. Locations are going to be either point, line, polygon, multi-polygon, and what have you, but they cannot be a feature. They cannot be a feature collection. However, in the response, of course, you can get features and feature collection. Right, temporal interface. I will suggest, just to give myself a chance to speak, we take a very short break before I start doing talking about temporal. So could we just have a 5-minute break at this point, and then I'll continue again in 5 minutes. I'm just trying to break it up to make sure we've got keep up the attention span. Go off and get a cup of tea or an ice cream, depending on how warm it is with you. And we'll come back again in 5 minutes.
Should we take a break for this section?
Yes,
or?
Yes, take a short break. Obviously, if you want to chat with other people in the various tables we've got, it's just trying to talk for 3 hours continuously is just not going to be interesting enough for anybody.
Okay, see you in 5 minutes. Welcome back, everyone.
Right. As you probably appreciate, I can't talk for 3 hours solid without stopping making sense. So I'm looking after myself as well, looking after you. Hopefully, it'll be more interactive, more interesting if we do take a couple of short breaks as necessary. And I've noticed that we've started getting some questions on the chat. So starting from the bottom, is it chat or Q&A? There's nothing on the Q&A, but there is stuff on the chat. So we do record these sessions. Over the course of time, FIWARE does have a load of videos. And if you really enjoyed listening to me, there's a series we have, regular Wednesday webinar series, which I think is now over 30 videos on various aspects of NGSI and the various elements of the FIWARE catalogue around NGSI. You can find full details, and I've got that for trust engineering FIWARE winners. There we go. You can find full details on the FIWARE Academy. FIWARE Academy's got links to various tutorials. It's got links to the step-by-step tutorials, which is going through the basic happy path of a vast majority of the components in the system. There are also additional links to the individual tutorials for the components themselves. As I'm sure you appreciate, the whole point behind this FIWARE system is that you can plug in whichever bits you want. So therefore, it's necessary to show each individual element in action, as well as showing how to combine, say, I don't know, Comet with Cygnus, or how to get a visualization by adding in a third-party component like Grafana. So you can see something actually happening online, but also interacting the various elements themselves. The step-by-step tutorials tend not to follow the unhappy path, and that's actually probably more interesting for most people, because you follow the tutorial, it works perfectly well, you do something else and it breaks. When it breaks, your best bet is actually to look at the individual documentation for the components themselves, or indeed their own documentation, because that will give you more insight as to what to do when something goes wrong. So yeah, we've got lots of videos under FIWARE. The Wednesday webinars are technical. There'll probably be a separate playlist for the I4 Trust training. We have, I think, is it 5 or 6 sessions, which will be going up there, and of course keep moving on additional stuff thereafter. Now, in the sample, the link header has type application JSON, and the link header has type application JSON. The accept header has application Geojson. Yes, the link header is defined within HTTP. I can't remember which RFC it is, and it consists of a pair of angle brackets around the URL of the additional information and some idea of the MIME type. So therefore, the link header is always, when you're talking about, there's also a rel saying what sort of thing it is. The linked header is going to always have a format which looks like, and I'll just take an example. Where are we? Postman, there we go. Headers. I'll put this in the chat as well. It's going to have a format of whatever the URL of the context is, followed by a rel, followed by a type. Now, the rel is saying what is the meaning of this link. In this particular case, the rel for every at context will be a definition of the context, which is in the JSON-LD context. The type will always be LD plus JSON, because if you look at the core context, which again, I'll have to ping a link rather than show it up on screen. Where are we? So let's pick a nice big context file, which is something like this. And I'll put this as a link, and you can all download this. This is actually the full set of smart data models. It's basically just an open bracket followed by an at context. No, I'm not in presentation mode. I'm just answering some Q&As at the moment. I'm just putting some links. I'll continue the presentation a little bit longer. So it's an open bracket followed by context, followed by a series of elements, which indeed is an at context. So I think I've answered the questions which are on the list at the moment. Please keep them coming. I'll now get back to doing the presentation. So see what's get back to my PDF file. Right, so I'm back at the beginning of the slide. Keep going back to the beginning of the slides. So I need to get to the right slide again. There we go. Okay, temporal interfaces. The temporal interface is, and you should now be able to see the stuff on screen. The temporal interface is an optional extension for context brokers. I believe that all three of the context brokers found in the catalog. Of course, you don't have to be in the FIWARE catalog to be a context broker. You just need to be following NGSI LD rules. And it is perfectly possible to have a context broker which doesn't offer the temporal interface. The temporal interface is being able to give you some sort of historical information associated with your entities. You might say, well, what about the fact that you've already got components in FIWARE that can already deal with historical information, things like SH commit, quantum leap? Well, yes, this is a duplication. There's no doubt about it that you don't necessarily need this for all entities or indeed all systems. It's really a matter of working out which elements you want to get hold of and use to build up your system. The temporal interface just offers a well-defined interface for getting that information out. So if you are following your NGSI LD specification, it will come out in this format. Now, as it happens, it's pretty close to whatever Quantum Leap comes up with, but Quantum Leap itself relies on subscriptions being raised to say something has changed. It also would not necessarily offer you temporal information for every single entity. Now, that could be a big advantage, because obviously taking each entity, every time each entity changes, is going to involve an awful lot of information, and you would either need to store it or delete it at some point. So if you can reduce it to just the stuff you want to get your line on the screen, then sure, by all means, use a component like Quantum Leap. However, if you want to keep a historical record of literally everything and get it out in a standardized format, then the temporal interface is the right way to go. The temporal interface is very simple, really. It's very, very similar to the standard /entities endpoint. It's just now under /temporal/entities, and there are a few additional parameters you can put in. And again, find a little video to show you on that one. You can actually see information coming out, and a few points about temporal. I've started writing a tutorial on this, and to begin with, the performance of my little tutorial system was awful. And the reason why was in the tutorials in particular, I'm just trying to get the smallest system working with the least configuration. And you need to start thinking about a proper configuration when you start thinking about a system which requires temporal entities. So, for example, by default, apart from this one, the tutorials offer you full debug, because you might want to look at the logs, because it's a tutorial, right? Now, obviously, if you are trying to retrieve thousands of entities a second, you don't want to run as debug, fairly obviously. But a few other nice little gotchas which I discovered. The app context file, which you have, it's probably best hosted by a separate container if you're talking about a Dockerized system, so that if you have a request, like as you can see there, there's a link header to the a public path to a context file, then there's nothing blocking it. It needs to be able to retrieve it when necessary. Sensible context brokers, and yes, they all are sensible context brokers, will not read the app context file every single time. They will cache the context file, but they still need to be able to read it as necessary. You can see from that little request we've got there is that, as you'd expect, the tenant is necessary if you're trying to get hold of information for a particular part of the multi-tenant. And what we have there is just get hold of the last n entities, last 5 entities. The responses you get, I think that's the next slide. Yeah, the responses you get, and it's going to be easy to see this when I'm showing the video, are potentially very, very long. Obviously, you will get the full information about whichever attribute you've got, which has got a value, and potentially they might change or not change. In this case, on the left-hand side, you've got the name of a cow. And funnily enough, the cows don't change their names very often, but every single time there's a reading, every single time there is a modification in the context, or for that matter, a repeat of the information of the context, you should get a reading, because context brokers deal with the now. And if I say, right now, the name of the cow is Beanie, and then 5 seconds later, I say, right now, the name of the cow is Beanie, I have more confidence that the name has not changed. So even though you have static data has got repeats within the system. More useful is when you are talking about temporal information, is when you have obviously something that's changing. Now you have a value changing. Now you have a value. If you have a value and it's a measurement, you are not, I don't think mandated, but certainly highly recommended to use unit code, which is UNCFAT definition of what the units of the entity are. Unit code itself is a non-reified entity, non-reified attribute, sorry, which means it doesn't have a type or a value. It's one of the few which doesn't. But the other one which is really, really important, particularly for temporal information is the observed at property of a property metadata. And observed at is saying this is when the reading itself originated. If you imagine a system like a farm, you could have an MQTT system where it only wakes up once every half hour and asks, have you got any readings for me? You don't want to put into the context broker the fact that I've received this reading of this bunch of readings right now. You want to receive, well, it was taken at 5 o'clock this morning. Or you could get a batch which could put lots of little changes all in at once and say it was done at 5, 6, 7, 8, 9 o'clock. Every single time moving on the next little section. So observed at is used to, by default, key the timings. You can actually use the timings on the modified at, in other words, when it was received in the context broker, but that is probably not going to be as accurate as using the observed at. This was one of the issues in getting Quantum Leap up to using NGSI LD, is that at the moment Quantum Leap is using the subscribe time, which, okay, for a fast-moving system, every time it's received by the context broker, it's going to get a subscription date, but it will be. Whilst you're saying the URL is slightly wrong, there's no R at the end of it. I'll put you. I can put ping the link in as well. Just a minute, I'll find it for you. That's the thing there. It's not Composer. It's Docker Compose under that tree. You can download the short-term history tutorial. In fact, we've got lots of tutorials here. This one is a work in progress, so the actual texts are not in alignment with the functionality. I haven't managed to complete it yet, but this is hot off the press. When they are completed, they are when the NGSI LD tutorial branch is the equivalent of the NGSI v2. It is then added to the actual proper documentation, and the README is enhanced and what have you. Okay, so where was it? Okay, so yeah, so one of the things which Quantum Leap was doing is taking the subscription value. Now, one of the enhancements they are putting in at the moment is to look at a hierarchy of the sub properties, to use those in preference to using the subscription as a fallback, because now, unlike the NGSI v2, there is a well-defined value to put in here. So you are able to get a hold of this. In NGSI v2, which again, Quantum Leap can use, and it's, let's say you're using the IT agents from Telefonica, they would call it timestamp. No, time instance, sorry, time instance. Now, because ETSI are a specification body, they say, use this, therefore we use this. It is possible to do requests without the observed at attribute, because observed at is not necessarily a part of the data. Every single attribute is modified at, because I've received data, context broker says, yeah, I've received it right now, that is the modified at. Or I received data, it hasn't changed, but I've received that right now, this is the last time I am confident that this attribute has been done. So that's always modified at. But observed at, although observed at is the preferred value, it is not mandated in absolutely every attribute. Every attribute must have a type, it must have a value, but it doesn't need to have anything else beyond that. It doesn't need to have any specified metadata. So it is possible to extend this with its time properties value. So say, oh, by the way, I want modified at as well. This is really, really useful if you want to do a Q parameter query around the temporal stuff, and I'll show a little bit of that later, saying I want to, so have I got that on there? Yeah, so you can see there, fourth line, Q sex. The sex of the cow is not going to change, right? So there's not going to have an observed at value for the sex of the cow. So if I want to find out that particular piece of information, I need to be able to look at the modified at as well. It is therefore necessary to use this when querying static values. And the response coming back has got the additional value. It's got the modified at as well. You can see within this value, you've got an instance ID added to every attribute and sub-attribute, I believe, entity. I'm not sure. I'm going to check that one. And this is because ideally, with your temporal information, you should be able to delete elements which are by reference to their instance ID, which are in the historical state. Right. Before I go into too much further, I'm on 12. Okay. I'll just show you the final little video I've got here. It's the last one I can actually show in action, because this is the one I've actually got working for me. So let's see what we can do. Stop presenting for a second. Go to my temporal video. Move it over here. Let's see some of these temporal actions in action. Okay, so you can see, if you look carefully, this is looking at localhost 8080. This is a different port to the usual one for Orion LD, which is 1026, because the whole of the interface is optional. So it's actually a different component. It's called Mintaka, which is used for adding stuff into Orion. Okay, so let's have a look at this. You can see, looking at the headers, we've got the tenant here, and we've got the usual stuff for LD, as you'd expect. And then for the parameters, we just get the last n results for cow1. You can see that the actual response is even just getting the last 5 things over a kilobyte, and it's quite extensive, because we're doing this normalized value. You've got automatically things like an instance ID added into every single element, and you've got other information as well. You can actually use the modified at here just to get the sex female, which is the second one, which was going up on screen, and that will then give you an additional element onto each one. So phenological condition and legal ID have also got modified at, which they didn't have previously. You can also do Geojson or geofencing or time information. So the time at and time rel, you can see at the moment, I'm doing this back for some date in April, which is the first time we ran some of this stuff, and you can get lots of information, and it's telling you when you're getting the stuff. I just pause that for a second. You can see, if you look carefully, the format here is actually the lighter version. This is called temporal values, which is the equivalent of key values. And each element, like in this case, it's currently scrolling over the locations, just consists of an array of 2 elements for each part. So you've got the array, which is the values, the point, and you've got another element, which is the usually the observed at, saying what the time is. Now, in this particular one, you can see that I was running this system at approximately 1:45. And if we just continue on with the video now and run it again, I change the date to sometime after that, you can see that you can actually filter before or after your various times. So putting 45, that was 44 was the one on screen, and another request. Instead of getting quite so much, you get in this case we're only getting half a kilobyte of information as to what was happening there. As you can see in the case where you've got multiple objects, you can have arrays of information in the system as well. This one it goes through the various parameters, which we can go into more detail. And you'll be pleased to know that's the last one of my little live demo. So I'm going to go back to the slide deck again. Okay, so as you can see, the normalized request was huge. So there is this additional, and we've done that one as well. And that one as well, we've done. Yeah, okay, that's about where we were at. The normalized one is huge, but there is additional formats you can actually look at. Pagination, you can split this data in multiple different ways. Obviously, you need to split this data because otherwise your response will be literally megabytes. It's a case that last n will get you the last results for a particular attribute. You can also have a maximum number of entities returned. So I could get the last 5 results for with a maximum of, say, and that was the case I put there, was 2 entities. I have a herd of 30 cows, I think, on that particular example, but it was only returning 2, and it was still a kilobyte or 2. Now, if you are reducing the number of entities to return, you need to be able to find out where to go next. So you've got the options page anchor and count to be able to give you additional information. The page anchor is do this request starting from this entity ID. And as you can see from the relevant headers, it will tell you various bits of information, including next page. So in my particular request, I had give me 2 cows, and because I limited it in the header, it says, yeah, I have a maximum of 174 cows. I'm displaying 2 cows, and my next anchor is cow 4, and you can then add that into your next request thereafter to say, okay, now give me the next elements. Now, if you are doing a between time period, obviously that means that the request should, unless you're adding in additional information, the request should be idempotent. Obviously, if you get the latest and then get the latest a bit later, it will give you the latest up to the now. It's always talking about the now. So doing a request like this, with just last in there, is not idempotent. So you should beware that it's likely to change if you do refresh multiple times. The content range, again, is useful because it will tell you the range in which of dates which is received. which obviously when you're talking about last n is quite useful because you don't have to go through all the values and therefore what's the earliest one, what's the latest one, it's done for you. So there are multiple headers which are associated with the pagination, and it's possible to get more information out so that you don't have to do everything all at once. As you'd expect, this is temporal, so we're going to have mechanisms to limit the time to arrange. At the moment, your options are either time rel before, time rel after, or between. You've got time at, and I think time at end as the one additional one which you use for between. But if you've got just one of them, it's just time at. And furthermore, you can use all the parameters which are defined for the entities endpoint filtering here as well. So you could filter, give me elements of type device, give me elements of which are within 800 meters of a location. I think it's the Brandenburg Gate. Give me all readings which are taken since 8:30. So again, this is an essential, frankly, because the timing, if it's going to be useful, needs to take an awful lot of data so you can watch trends and big data analysis and stuff like that. And if you're going to try and receive the information in a relatively timely fashion, you're going to have to restrict the range you're talking about. It is the case that adding temporal will slow down your context broker. It is the case that the information will take up memory, and therefore you need to restrict things if you're going to do anything worthwhile. Yeah, temporal values response. As you can see, it's a more terse version of the same piece of information. Right, and that is a quick introduction to temporal. Now, I haven't got any more videos, you'll be pleased to know, for the next section. So this is all going to be just pure slides and talking heads. There is a new concept within NGSI LD called language maps. And the reason behind this is that there is already an existing equivalent in JSON-LD. JSON-LD defines in its operations ID, which NGSI has also got ID. It defines type, and NGSI has already got type. It defines value, and we've already got value. But one thing which you can do with JSON-LD, which you can now do with NGSI LD, is language. Now, the JSON-LD at lang directive is used to define the natural language of a string, and this is just, we've inherited this from JSON-LD. We are an extended subset, sorry. And then you can get hold of the information as necessary. So JSON at language specifies a language for each particular property. So you can see within the highlighted element, we can create an attribute called street. And because it is a simple string, you can give it a type of language property, in the same way as you can do property, or geoproperty is now language property, which instead of accepting a value, accepts a language map. This is the equivalent of the geoproperty, which already accepts a coordinates underneath it, for example. So you can see here that we can deliberately define a an attribute and say, hey, it's got one of these values. This means we can actually do a certain amount of querying over it, because we might, if we wish, to say, okay, give me this value in French. Only going to work for simple strings, because this is JSON only works in simple strings. But there's usually a range of priorities. If you go on to look in the settings of your browser, you will probably find that it says, okay, I would accept the values I prefer to get my web pages in English, but I would accept it in French or Swiss French or Canadian French, but then maybe there afterwards I'd like some German, and then if you really can't be bothered, just give me whatever. And this is defined using this accept language header. Again, it's defined by the HTTP people, so it is possible to request different elements of the system in order. Now, I can therefore make queries such as, could you give me the vehicles parked on the street called Grand Place? Or I could ask, give me the ones which are on the street which have the name Grand Place in French. It is possible to using this this lang edition to be able to get back information in multiple languages. Very useful, because there's a lot of static data, simple strings, in multinational locations, which the example here is Belgium, but most regions in Spain have got multiple languages. Even somewhere like Germany has got Sorbian as a minority language, or you've got the ability to do Danish in the border. A lot of authorities have got the need to have multiple languages, and then you don't necessarily want to query all the names in French if you're a Flemish speaker. You're just interested in the stuff thereafter. So it's this is for display of information. You can see that you get back an additional lang attribute if you lang property of a property, get that right, if you are getting back particularly one element. Language maps are just simple strings, so they aren't going to be particularly useful in the standard smart tourism case. If you're going to use language maps, you're almost certainly just going to be looking at smart cities, and it's just strings. It's not going to help you with everything else. However, you think about it, right? You have standard data models for things which are usable in smart tourism. The front runner there is the UNE definitions by the Spanish Tourist Board. So you know that a hotel is going to have an address, it's going to have a manager, it's going to have a various other bits and pieces. But what is useful in smart tourism is be able to say, okay, is there a walking tour going on which is going to take place in Spanish, because I don't speak English or whatever? Or is there going to be a choice of being able to get this with subtitles in French? Now, in order to do that, you are going to have to use standard semantic terms to be able to define language. And there are already various default terms here which are used by schema.org for doing this. So this is an example. I'm going to get quickly. Sorry. 2.5 hours so far. So you can use standard schema.org elements like in language and same as to differentiate these things. So if you have an event like Bonjour le Monde, you should have an attribute called in language, or an saying that this event is in French. And then you can have same as, saying that, bonjour le monde is the same as hello world or hello Welt or hola mondo or whatever you want to call it. And you can see each one of those, which again is a relationship because it's a separate entity, is going to have the language. So you can then have a query on this event in French. Reason why it's done this way is because if I happen to be in the middle of a monolingual country and I'm using a standard data model for this, I'm not going to have stuff in other languages. So in language and same as will be optional attributes which can be added onto the standard model. The standard model actually defines event, hotel, whatever, using standard terms. You can't get multiple things in one request, but you can get multiple things in a request followed by following the other elements of the node. So it would be possible to say, okay, what are the alternatives to bonjour le monde? And you can see from the request that you can find out more information about the other objects there afterwards. Expansion and compaction. This is because we are JSON-LD compliant. Everything that JSON-LD does, NGSI LD can do if you can be bothered and you want to extend this to another level. NGSI LD communications will be in NGSI. The outputs will be typically with the at context, either in the link header or in the body, but you are free to manipulate the information there afterwards to alter the data you're passing. At the moment, you could use this for supporting the at vocab. At vocab is one of the things which is still under discussion with ETSI, such that you can use a value which can be expanded in the same way as attributes can be expanded. At the moment, that is not part of the core NGSI specification. But what you could do is you could get a response, and then you could say, okay, now apply the following additional context on top of that response. The example I give in one of the tutorials, I end up with data which is in pure Japanese. Now, if it's purely in Japanese, it hasn't got things like type or value or whatever in the normalized response. It's got the Japanese characters for those. So it's not, strictly speaking, NGSI compliant. However, of course, it is JSON-LD because I'm supplying an at context saying what all the attributes and the values actually really mean. So you need to be careful here that if you do apply expansion and compaction, and of course the JSON-LD guys have got videos on what this actually does, you will end up with valid JSON-LD, but you won't end up usually with valid NGSI LD payloads. And here's the example I'm giving. You can see the items highlighted in green. The items highlighted in green are mandated for NGSI. You must, if you have a geographic position you want to use for geofencing, call it location. You must call it have a type attribute and type. And you can see a lot of the information has been translated. You might notice that the address, although the type and the value for the address have been translated, the sub-attributes have not. And the reason for this is because my address is a schema.org address, as is that Japanese character saying it's a schema.org address. And therefore, the object it's got, which is just a standard JSON object, is going to have whatever attributes you would expect for a schema.org address. So it's still got an address locality, a region, and a postcode. This is just a sort of example of the sort of thing you can do manipulating your JSON-LD once you're out of the context world. You still use the context for the NGSI LD context brokers and what have you for moving context around your system, but you can do what the hell you like afterwards. A little bit more on languages. Context data is data for exchange, as we pointed out. There are rules to NGSI LD which actually don't even apply for JSON-LD. And the reason for this is that you need to be able to understand me as well as anyone else. Therefore, it does not do natural language collation terribly well. You can't define a data interchange format and allow people to put, say, dates in French, because it's not a computer readable system. The data inside the system is readable by computers. So your strings are going to be Unicode strings, which means we've got a problem in that if you want to, say, list all bus stops beginning with the letter A, how are you going to deal with accented characters? Well, if you're, say, Spanish, you're just going to ignore them. But if you're, say, Swedish, your A with a little dot over the top, circle over the top, is a completely different letter. And there's also no guarantee that you will, your letters will run from A through to Z. If you're Lithuanian, you'll end up with the order of letters is completely different. Well, it's not for context brokers to deal with this sort of thing. If you look at databases, natural language collation in databases, the way they do this, and I say, you know, I want German address book order or Swedish order or what have you, is that they hold an additional index to get hold of that information. And this is the way forward to do this with context brokers. You can add metadata to this information, and as you can see, what you could do is you could create your, let's say, a street name in Spanish, and then when you proxy before the system and say, okay, not only do I want to have the name of the street, I also want to lowercase and get rid of all the accents so I can search for this later. And there's a simple little bit, I think it's JavaScript, just used NDF format, which is, and then just remove everything which is a non ASCII 0 to 256 character and lowercase it, fine. Or I want to replace all my O's with umlauts with OE and what have you. You can do that in German. Similarly, if you're talking about dates, all the dates in the system are going to be Unicode dates, which means that you know that your data is standardized. You've got opening hours, it's going to be a Unicode date. Okay, so if I want to display this to a customer properly, it's your problem rather than, or a proxy for the context broker's problem rather than a problem of the context broker itself. Context broker is just holding the fact that, you know, currently we're opening on Sundays, and then you can change that to be a different language. So the example we have here at the bottom line is that it is perfectly possible to create query a property of a property. So if you have a name like Monsieur Necruse, you can just instead of checking with a regex expression, trying to get rid of umlauts and add in additional bits and pieces, what you have to do instead is you have an attribute called collate, and you can push collate into a sub attribute and just check that instead. Further information on context broker anti-patterns. Don't use regexes to try and set up your A to Z either, but this stuff should make sense. Don't use a context broker for everything. Context broker have a state representation of the real world, but it is not a database. It is not a file storage. It is not. It is designed to have either links or texts or simple JSON types, Geojson types, or effectively JavaScript primitives. So it won't deal with binaries. It won't deal with complex queries. What you need to do in that case is to add into your context broker a link to another system. So imagine, for example, you are taking images of number plates and you want to store that into some long-term storage somewhere. It would be the link to the long-term storage to get hold of the image itself, rather than actually trying to place that into a context broker. I can't remember what it was, but there is a limit in size of the pattern you can put into a entity, and if you're putting in too much stuff, it will slow everything down, and it's not readable. So you should think, can this data is this data put in here properly? You get a similar problem for predictive stuff. So, for example, if you want to find out what is the traffic going to be next week, or what is the traffic going to be in the next 15 minutes, you are probably better off either having a link to a URI saying, okay, if you want to find out what the predictive value is, go over there and use that link to get further. Or the other alternative is to have a cron which would, if necessary, update the information on a regular basis. You can use things like Cosmos to give, an averaging value would be another example, and then you can add that back as an attribute. But you don't want to keep updating that every second. You'd be much or microsecond every time the thing changes. You might want to flatten out the value, just do it on a periodic basis. So in that particular case, you're hiving off the calculation of the average or the calculation of the prediction to another microservice which can do the job properly. That would have a context provider interface. Obviously, you'd subscribe and you'd pass the ID of the entity, and it could then push back into the context broker there afterwards. But the takeaway from this slide is purely that context data is just data, and if it doesn't easily fit into the system, it probably shouldn't. We're not a database, and we are not usable in all situations. We're usable context data. Let's move on to some filtering. There's absolutely no sense whatsoever in getting the full NGSI LD stuff all the time. You should endeavour to reduce the amount of data being passed around your system if you need to navigate the graph, because if you need to make multiple queries, get hold of the relationships, get hold of the IDs of the relationship, find out which ones are responsible and what have you. You can do that in multiple queries. And in this particular case, you can get hold of filtering by types, attrs, or ID. Now, there is a /types endpoint, so you can find out, well, what types are there currently in my system? And then you can use that to say, I would like to get hold of, the pigs, like get cows or whatever. And for the attrs, if you have a list of attributes which are part of your request, it will only add those. Also add in the ID and type by default, but you can just restrict it to the attributes you're actually interested in. One case about ID is that ID should be unique within your broker federation, because obviously I know what something is and you know what something, and the rest of my system that agree that I have a viewpoint on this entity, and it's the same entity for you. If you're talking about external systems, you might want to consider if the model itself has got a well-known, well-defined unique ID you could use, because obviously I might assign a different ID to my cow than the vet does, and that is most easily done where there is a model where there is a well-defined unique ID, legal ID, social security number, whatever it is, so that you can use that as the basis of your querying as well, an attribute. Each one of these obviously takes a comma separated list, so you can say, give me the types for cows, pigs, tractors, whatever, and same with the attrs, you can take the short names. But this is a gotcha for NGSI LD. If you're using short names, you've got to make sure that they are the short names which are defined in your context, because if you're trying to look for, you're not actually looking for the attribute short name, you're looking for the attribute short name, which is then expanded to the IRI inside the context broker, which is then used to check for the database. So if I'm talking about location, for example, it is going to be a URI etsy.org/NGSILD/location in all cases, and then that obviously helps with data exchange. Similarly, you can, you've seen this on the previous video, key values, it just gets you the data, but it doesn't get you the metadata. So if you want to find out that the temperature is 30, you won't know that it's 30 degrees centigrade or whether it's Fahrenheit or Kelvin or whatever, which obviously makes a big difference, but it's perfectly useful for external clients. When you're talking about between various different data spaces, then you're going to be using normalize. Normalize is mostly used for either data exchange or big data analysis. Big data analysis won't work unless there's sufficient information within the system to say what's actually going ahead. Right, Q parameter. This is one thing which I usually sort of lead over far too quickly. It's probably one of the more powerful parts of the NGSI interface. You have got these different patterns you can use, like equals, unequals, greater than, less than, blah, blah, blah. But it's used within both queries and subscriptions, and it's very useful for reducing the amount of data you get and also getting the information you really want. Now you can see from the examples on the screen that you can modify your Q parameter using brackets, and this will obviously change the precedence. I can't remember what the default precedence is, but you can be guaranteed with brackets. It may, I think it's and doesn't work without the brackets. You can see, for example, the second line has got a temperature range and a capacity less than 10. Now there's also a specific dots example which will do the same thing. So if you want to do a range from 2, it will do, you just do number dot dot number. Obviously that's going to be a shorter request. It is possible to look for elements within an array, like the barn or farm auxiliary, which is the example I gave yesterday. It is possible, because the data can be treated as strings, to do things like a greater than date, because obviously URI dates are going to be beyond a certain value. And the one at the top is obviously saying it's an either or, so it's either speed is greater than 50 or RPM is greater than, and the brand name is Mercedes. That's the reason why you need to get this order. Some of the other, I think one of the others you don't necessarily need to do. You can use the Q parameter on sub-attributes. If you are dealing with this, you may well need to URI encode certain things. So as you can see the example of city address being Düsseldorf, I've URI encoded the U umlaut. But as I said earlier, they'd be much better to, if you just do collation, and then you can avoid nonsense like that. Geofencing, again, because you have location by default, you are able to get hold of information either with various different GeoRel options. So your geometry can be based on any supported type, which doesn't include feature and feature collection, but it does include things like points and lines and polygons and what have you. And you can then either look for stuff beyond a point or within a radius, within a well-defined set of coordinates, or the various different additional options. It may well be necessary to URL encode the square brackets. This is not really a problem when you're talking about machine-to-machine communication, because they tend to do that automatically. But if you are like me, using things like Postman or curl to just test stuff out, it may, depending on your interpreter on the context broker side, it may be necessary to do some of this. Encoding. There is another well-defined attribute called observation space. I think it's operation space as well, if I remember, which is defined for the various different types of geocoordinate. Obviously, location is the most common one, which is why it's used all the time. But there is the area in which a device operates or can be observed. Once again, you're going to have to look in the specification for the details of that. So if you are looking for stuff which is happening within a certain area, you may want to use observation space for your model. Having described the attributes and the geometry of the attributes, and the types and the IDs, the final way you can do the splitting up of your data is, of course, the temporal version of the Q parameters. This I described earlier in the demo, but it's basically time at and end time at. The default, again, like if you look at the previous one, the default was location. As you'd expect, there is a reasonable default for the time property here. So it would be possible to do temporal operations on some other field where it is supported in context brokers. Observe that is obviously the one to go for the majority of systems. Right. This is where I take another break. I'm going to leave you with a question, which if you break out to the tables, you can try and work out how to design your system using advanced NGSI. Now, I, in my examples, have been using a smart farm. And obviously, I have designed the data models behind here. And you can imagine a scenario where we have a farmer with pigs and cows and track the animal collars, but we also have a third party. We have a vet's practice, which also has information about the cows, like is this cow currently in calf? Is this animal sick, or what have you? And we can also have, say, a weather service, which is agricultural weather service. Again, it's a third party, and we're trying to talk about data spaces here. So in the next break, which will probably be a 10-minute break, those of you who are interested, and I'll be asking questions later, can you work out from this particular slide, who are the data providers? What is the data which the farmer would own or purchase from a third party, like going through a system like i4 Trust? What common data models would you use in this situation, if you've got experience with the smart data models? And how can you ensure from the data from other sources refers to the correct entity? So at this point, I get to have my next little break, and we could come back at 5:30 European time. Right, so this was the question I left you with before I was getting on a bit more water because it's quite warm. Who are your data providers? What the data sources? What models should you be using? And this is actually a common scenario. The way you've got to think about NGSI LD is you've got to stop thinking about I'm pushing my data around. Is that actually what you're doing is you're pushing everybody's data around. The whole point about the linked data in general is that you want to share it. And if you want to share it, you need to follow, if not certain rules, then at least very strong indications, because you need to say, okay, this needs to be available in a format that somebody else will be able to find useful. So in this particular case, your farmer is going to want to receive data from external sources in the format that will be usable and then potentially saleable onto other systems. Right, let's look at what we've got for the data models first. The smart data models has got a series of models covering a wide range of context data-based scenarios. And obviously we're talking here smart agri. So in this particular case, you would expect that there would be a model available which is coming from the appropriate agricultural domain. Well, we've got cows and pigs, so you'd expect that the cows and pigs would be have a standard model. Yeah, it's animal. You can extend it as necessary. There could be additional things which would be required for either a system, more fine-grained system, or there could be different things which would be available on pig and cow, for that matter. But the basic data model, the type I would assign to the animals themselves, would obviously be animal. Similarly, if I'm talking about the weather, obviously the weather is going to happen in a place, and it would make sense to use the standard agri-food model for a field where I'm trying to find out the information. So the field itself would be coming from the agri-parcel model. This means that I'm already starting to define not only the entities in my system, but the likely types, attributes in the system, and the likely names of those attributes. Because that way I can share the information that, hey, I've got this particular field, and I'm not making it up as I'm going along. All of these things exist already. The interesting case in point with IoT devices. IoT devices are almost always going to be using the device data model. There's also a multi-device data model these days, and there's some more in robotics. But when you have something like in this case, heartbeat monitor, then the device is making that reading, but there's also a linked entity, the provided by using the provided by relationship of a property at this, and again you've got the observed app saying when it happened, to push the same data onto the actual animals. So there's no problem when necessary having duplicate information if it's properly annotated with the metadata, because if you can ensure, and indeed the IoT agents do this, if you can ensure that when the data is updated in one place, it's updated in the other, in other words, it's a batch update, then it's perfectly possible to say, for convenience, I want to place this information here. Because I will be able to use it. And obviously, what the whole scenario was trying to get at was that you will need to have your data and your metadata in such a place that I am able to use the information as necessary. Now, it's fairly obvious that both the farmer and the vet would be using animal as the basis of their system, but the weather service itself is likely to be using some of the standard environment entities. In this particular case, obviously, we're talking weather observed, because but it could be a weather forecast, it could be other information if necessary. So this goes back to the point. Let's have a look at I have animals in my system on my farm, but I'm trying to get additional information from the farmer. But the nice thing here is that although I am able to uniquely call my cows 1, 2, 3, 4, 5, it's not necessarily a globally shared identifier. It's legal ID. Legal ID is globally shared because legal ID is one of the mandated fields of animal. Every animal must have usually there's only a handful of mandated fields, because the whole point about your data models is that they should be extensible. However, when they are mandated, they're mandated for a good reason. And in this particular case, we say legal ID is globally shared, which means that I can then request data from elsewhere based on that legal ID. It's a bit different with I don't know if I've got that next slide. Okay, so it's a little bit different with the weather service, because if I have a cow and I want to track what weather that cow is experiencing, the cow does not have an attribute, it's raining, or the cow does not have an attribute, it's currently sunny. So you can't legitimately add any information about the weather directly to the animal. Makes sense. There is, however, within the animal data model, an option to have a located at. And located at is the cow is currently in this field. And that is going to be useful information, because obviously you can say, find out where it is, and if the cow is located in a field but the location attribute is saying it isn't, then you know it's escaped information like this. However, let's say we wanted to find out whether cows walk more when it's raining. You need to have, cows lie down in the rain, that's right. Let's say you wanted to find out, you need to ensure that the data is available so that you can do big data analysis or some sort of historical information directly on the animal entity. And the only way you're going to legitimately put that into my animal data model is by putting this as a property of a property. And you can see here that we have duplicated the weather conditions attribute from the weather. What's the name of the model? Weather observed. We've taken duplicated the weather conditions attribute from the weather observed model, so that you can have weather on the actual cow. This is legitimate, and the weather conditions has got defined within it additional sub-attributes of that property, such as the temperature or what have you. So we know from the name of the attribute that it's and the type of the attribute, it's going to hold the various additional elements. This is because you've defined the in the context, weather conditions is a well-known short name, so you can say located at can have this sub-attribute called weather conditions. So weather conditions is a property of the relationship, and it's purely for convenience. You need to do this sort of thing because depending on your system, you may or you may not need to have requests which span multiple entities. Ideally, everything you can retrieve in your one request. So put it here, duplicate it, it's not a problem. With the vet, it's simpler than with the weather forecast. So moving into more details, how do I get the data? Okay, I would create a patch to say update the phenological condition, reproductive condition of the animal in the veterinary practice. And you can see that here I have an attribute I'm placing here saying. No, it's the wrong way around. I'm doing a pull rather than push. Sorry, got it completely wrong. So, okay, I have decided to create a new attribute on my animal called refresh vet data, and at that point, I would then request the relevant attributes, which I wish to then refresh on my actual animal model, and then. Patch. So I send a patch saying I wish to update this attribute. It's like an actuation. My actuation is refresh vet's data, and I've got the value of get the following fields. Now I could also include a subscription on that, saying that whenever and this is a typo in the field, it should be whenever refresh vet data is as a watched attribute has been updated, has changed, then I wish to be notified of the legal ID of the cow and the the data within the refresh vet's data. At this point, I can send this to an endpoint, and the endpoint in this case is saying, this is my I4 Trust app, and it's going to veterinary practice. And there is sufficient information in that request because it will have the phenological condition, the reproductive condition, the legal ID, and the ID in the farmer's system to be able to start doing the necessary additional business logic to potentially negotiate a price from the farmer to get hold of the data, let's say, because we're selling the data, or make the relevant security request to say, yes, I am Farmer Jones. I am legitimately asking for this information for my cows. Can you please tell me where the data is? At which point, of course, you could then make your request to a third-party system. The third-party system would give you back data in NGSI LD format, and you would be able to interpret that or the parts of the model as necessary to make an additional patch back onto the animal as held by the farmer in question. So as you can see, you can use subscriptions to create your own break between the my data and data I'm getting from a third-party service. It would be possible to use registrations. The main use for registrations is when you're in a federated system where you actually trust people. Particularly in the databases scenario, I'm thinking makes more sense to use a subscription here, which says, okay, effectively the endpoint I4 Trust veterinary practice has been supplied with sufficient information to be able to complete the transaction between data space A, the farmer, and data space B, the vet. Option 2, you could use related sources. Again, this is following the smart data models definition of fields. They've already got well-known names for various different parts. So let's say I have a field, an agri-parcel. It's got a set of coordinates as to where it is, an area, what type it is. But one of the important attributes you can get there is called related sources, which is an array. And it's an array of objects with key value pairs, one of which is the application. So you can see here that the related source holds sufficient information to get hold of, saying, hey, when I want to get weather for this bit of land, I need to make a request for that particular URI from the app called External Weather Station. So at that point, you can see that this, using this similar mechanism, you would be able to say, okay, now I can just go off and request the weather conditions, and I can hold the weather conditions on the agri-parcel, or rather the full weather conditions on the agri-parcel, and the necessary elements such as whether it's raining, from the on the cow. So it is the weather conditions are associated to the piece of land, which makes sense, and it's the if I go back to the previous slide, oops, and you can see it's the property of the relationship, which means that I can get the information direct on the cow. Another part of this is that obviously, having got the information here, we can just do a patch on that that weather app. So you can again subscribe to changes to do a refresh of the data, and obviously once we receive the information from the weather app, and I think the way it's been defined here is that you can, oops, go back to the previous slide. You can see that you've got the ID, the necessary ID. It wasn't a legal ID, but the necessary ID and the related source. You can then make the request here, saying, okay, I now want to do a potentially update weather. I need to get a weather update, and then I could be notified, oh, I'm doing this, the weather has been updated. I then need to cascade that back down to the various elements, such as the agri-parcel and the animals in question. Right, this is an interesting question, and indeed, if you get Alberto Obea's viewpoint on this, of the same viewpoint. Strictly speaking, there should not be weather conditions in an animal. An animal is not sunny, but it is just easier so much easier if you've got the data in the right place. Now, provided you are talking about properties or attributes properties, there's no problem in doing this, because you think about it, the ontology is not perfect, but it's usable. And the whole point about your smart data models is that these are used models. We're not just coming up with academic terms. So, okay, strictly speaking, maybe this isn't the way you would want to do it, but where you should do it if you're being an academic. Sorry, but it's much more usable to get the information as necessary. It's obviously there will be a downside to putting stuff wherever you want it. You'll need to have more data storage potentially, and it could be more difficult to include interoperability. However, this shouldn't be difficult if you can reuse common attribute names. There is this attribute called weather conditions. It is weather conditions. It's well defined. It's in the at context, and it's got all the additional information. So yeah, you can get away and use it. Right. The other way you can do this, or other ways you can do this, try to get data into your system. Typically, and these are all to do with various degrees of trust. If you are dealing with an IoT agent, an IoT agent is typically associated to a single context broker. And if you look inside the system, what it's doing is it's just doing entity operations upsert. This is also true if you want to have a device which is talking direct to a system. And if you have a system where, I don't know, once a day I'm reading a file and then pushing that as context, same sort of thing. You'd write your own custom version which would do the entities upsert. If you have devices which are purely using the CRUD operations, they are then very, very flexible in using any context broker you like, or any connection you like, because there's no strong bind between the device and the context broker. Context broker is just receiving context has been updated, and then receiving context has been updated again. It's got no concept of ownership. Now, registrations here are a bit different, and registrations can be used for either federated environments or actuations, but not both. The point being that if I have a device which is actuating, it then means that I have a context broker that has an attribute which it can't deal with, but it knows who can. And that registration is linked to that context broker. And as such, it is necessary to have a strong link between one context broker and one IoT agent, for example. The alternative, which is used in federated environments, is where you have a high degree of trust between the system. Everyone's pooling their knowledge, and it's more a case of context broker one says, shouts out to the pool saying, what does everyone know about entity XYZ? And that's received back in return. So there's no ownership in or currently in a federated environment, and therefore there is a conflict between the two. This is something which forwarding context is something which is currently being discussed within the EDSI committee to actually try and work out how these two viewpoints can be combined, and eventually it will be. It's not a problem, but you should be aware of this. It may well be the case that when you do a registration in 3 years' time, there needs to be an additional field added in or something like that. Subscriptions can also be used for actuation, in that if you have a receiving endpoint, and I say, okay, whenever something happens in the context broker, tell me about it, and then that is used to do the actuation, the device there afterwards. And that indeed was the paradigm which was being used for the retrieve the values from the vet. Well, I've been going on for 2.5 and 3/4 hours, so that's where the main bit of the presentation stops, and I can actually start moving on to the Q&A. So I'm going to start. If you've got any further questions, I can see 2 up all there already. Start typing them into the interface, and you've got me talking for as long as I can keep going. Right. So question 1. How to manage data streaming from edge layer, e.g. using any nebulous streaming? Well, there's a media streaming component in the FIWARE catalog called Currento. Currento can do things like peer-to-peer communications. It can do online calls and stuff like that. But as far as FIWARE is concerned, the main point here is to be able to transform a video stream into a source of context. Now, you could, in theory, have a Currento instance looking at a camera on the edge, and that you could create a hook to say, okay, once X happens, once say a number plate is identified in front of the camera, go off and do something else. Now, that's as far as Currento deals with it, in that if you want to do, say, an upsert to my camera entity, that would be the job of a little bit of business logic, which you could write on top of that. Indeed, in the presentation I gave for the FIWARE Smart Fest a week and a half ago, I pointed out that Currento doesn't need an additional update for NGSI LD, because all you need to do is to actually write the logic to do an upsert, and the upsert will be based on whatever information you have placed in the system, because typically a media stream is linked to, say, a camera, therefore it's got an entity. So you could do that for the raise an event. I've now got something in front of my screen, and presumably, if necessary, you could do a storage event as well as part of your custom processing to say, okay, take a screen cap, put it onto some sort of cloud storage, and use the link to that as part of your entity changes. So we don't deal with binaries directly. So because it is use case dependent, there is no one way of taking the information and dealing with the information. But what there is there's one open hook for doing that. There is or there are a series of tutorials on the Currento documentation which deal with all sorts of bits and pieces. There's a few of the beginner ones which are within the FIWARE stuff as well. But if you're interested in video information, that's the place to go. Look at the Currento docs and see how you can get the information out there. The problem with video stream is actually getting good libraries for actually recognizing the event. and because if they're any good, then you have to pay for them. So that's the first part. But once you've got the event coming out, you should be able to get sufficient data to go elsewhere. Right. The second question on the list is: can the temporal interface available with Orion LD? All right. Be a replacement for a back-end timestamp, though? Maybe I missed it, but does it keep all the history? Simple answer to that is yes. The temporal interfaces are typically backed by some sort of timescale database. Within the case of Orion LD, the Mintaka edition, I think, is using PostGIS with a timescale edition. So that would then hold the full layer of information you've got about the timing of when what happens. You can use the time at with before or after to get the range of stuff, and there are a limited number of functions you can get through your temporal interface. It is possible that you may need to have another component if you wanted to get some sort of functionality which currently isn't in there. It's unclear to me if something's missing, whether you could extend the interface to get information from elsewhere. Probably not. It's best to try and keep to the standard stuff. So if it doesn't do what you want it, and I don't think at the moment within the defined interface there are that many, say, aggregation or averaging functions. I don't think you could put that in at the moment with a request direct to the temporal interface. But of course, what you could do is you could say do a broader query and then do some sort of operation on the response. So the usual answer to this sort of thing is, if it's a standard operation, great. If it isn't, like collation, then you will need to manipulate your data as necessary. So that's me done. So thank you very much for tuning in today. You've got my details, and I hope you're going to enjoy using your NGSI LD knowledge.